All right, pre-calc, my notes are kind of crammed in here, but we're finally getting to the heart of logarithms and what we've been looking for this whole time. So I find this stuff extremely fun. It takes me right back to Algebra 1, which is a blast for me. I'm sure you're thinking the same, right? All right, so let's go ahead and look. We are on lesson 3-4, and we are solving logarithmic functions, and this is why we've done everything we've done. Our essential question is, can you solve simple exponential and logarithmic equations? And we have a couple properties that you've already looked at. A to the x is equal to a to the y if and only if x equals y. Log base a of x equals log base a of y if and only if x equals y. These are called our one-to-one properties. The inverse properties we've gone over as well. A to the log base a of x is x. Log base a of a to the x is also x. So we have to learn how to solve these problems. In example 1a, I have 2 to what power gives me 512. Now, I probably could put this in my calculator. 2 to the first is 2, 2 to the second is 4, the third is 8, and figure it out. But not all the time do they work out perfectly. So if you get it in an exponential form, we're going to convert it to a log base. Log base 2 of 512. Again, if you have to use a change of base formula, you could just write that as log 512 over log 2. But if you don't want to, and you could put it in your TI-84, you hit math, scroll up to A, put it in just as you see, log base 2 of 512, and we know that in this case, x is going to equal 9. So the first scenario you're going to see is when you're given an exponent, and we don't know what the exponent is. That's where the variable is. Another scenario we're going to see is like this for B. B says ln of 5 minus ln of x is equal to 0. Well, I probably, since this is equal to 0, you know, sometimes we'd have to use the properties where we divide, but I'd probably just make this ln of 5 equals ln of x. And remember, if these are the same, 5 is equal to x. So in this case, x is just equal to 5. So this is one of those properties where they're equivalent. All right, let's look at C. C says, oh, it's an exponent. So what did I have to do when it was an exponent? We wanted to put it in log base 1 over 5 of 125. And again, you could use your log base 10 change of base formula if you would like to do that. Or you could just put it in as log base 1 over 5 of 125. And what do we get here for x? X is equal to -3. All right, moving on for D. I would star this because this is something you gotta know. Anytime you have an E, when you have an E, which is a number, you need a ln. And remember, ln is the natural logarithm. And anytime you have a ln, you need an E. So I'm gonna go ahead and make this 2 arrows so you can see that vice versa. So let's talk about what this is first, okay? I know that this is saying a number to an x power is 13. So this is saying log base E of 13 is x. But the way that I show my students to do it is we have e to the x equals 13. And I tell my students that anytime you see an e, we need a ln. What I multiply to one side, I multiply to the other. So these cancel out. The x comes to the front because ln and e is 1. And this is ln of 13. So x is equal to the natural logarithm of 13, which actually is a number. Let me go ahead and look what that number is, because I don't have that written in my notes. It is 2.5649. Now, if I had to do it this way, this is what I'm saying is happening. So anytime you see log base e, we know we need a ln. So that's just the ln of 13. So x is equal to ln of 13. This way, it looks a little longer right now, but well, it really doesn't. So same step, but this way is a little easier because you're going to see why in just a second. All right, let's look at example E. It says ln of x equals -8. Actually, I'm going to go ahead and write it down here. Ln of x equals -8. Again, what is ln? Ln is saying log base e of x equals -8. So it's actually saying e to the -8 power is equal to x. But I like to show my students that, once again, anytime you see an e, you need a ln, and anytime you see a ln, you need an e. But I tell them this is a kind of weird thing. We're going to put e to the, and these cancel out. So x is equal to e to the -8, same thing, no matter which way you do it. And I'm going to take e to the -8 and find an answer for you. It is approximately 0.000334. Okay, I'd probably just show it as e to the -8. All right, the last question right there says log base 10 of x to the -2. I'll write that out. Log base 10 of x to the -2. So all we have to do, if it's a logarithm, we're going to go ahead and put it in an exponential. So remember, I fly this guy. 10 to the -2 is equal to x, and I know that this is equal to 1/100.